presentation. Okay. So today we are going to learn about some properties. Okay. About some properties of continuous time Fourier series representation. Okay, representation. So this will be our topic today. Okay. So actually we are going to discuss very few properties. Okay. So if I tell you the properties, I hope to discuss linearity property, time shifting property, and time reversal property. So we will be focusing on these three properties. Okay, so these are very important properties. Okay, okay. I will use the note. Okay, I will use your textbook. Okay, because I couldn't remember the properties actually. Okay, so maybe we are going to learn this property. Okay, sorry, this property, this linearity property. Okay, linearity property, time shifting property, time reversal property. Okay, so we will be focusing on these three properties. Okay, these are very important. Okay, and actually this multiplication property is somewhat complex. Okay, you have to do some kind of convolution. Okay, so this multiplication property is somewhat difficult. Okay, so I will ask Dr. Udesh. Okay, because in last year we have done these properties also. Okay, actually we have done this time scaling property and multiplication property, these two also. Okay, so actually these are somewhat complex. Okay, especially this one. Okay, so I will ask Dr. Udesh whether, I think if it is not a must to do this property, we will ignore that one. Okay, and we will also ignore this one also. Okay, and we will be mainly focusing on these three. Okay, so anyway, today we will discuss these three properties. Okay, so the first one is linearity property. Okay, actually when you are saying the properties of Fourier series, continuous time Fourier series, those properties are always related with the Fourier series coefficients. Okay, so these properties are always related with Fourier series coefficients. Okay, that one you should understand. Okay, that one you should notice. Okay, so actually this properties means when we are changing the signal, properties means we are studying what happened to these Fourier series coefficients. Okay, so if there are any common thing to show, okay, it will extracted. It was extracted as a property. Okay, so actually when we are doing some question, we already use these properties. Okay, but without knowing they are properties, but already we have used them. Okay, when we are doing, maybe you can understand it. Okay, so this is not a new concept. Okay, we already without knowing, we already use this linearity property especially. Okay, but other things, other two properties, I hope we didn't use so far. Okay, anyway, we will try. Okay, we will try to do. Okay, so first the linearity property. Okay, so linearity property means say that if you have given a signal, continuous time signal, okay. So if you get the Fourier series representation, and say your coefficients are AK, okay. So these are your coefficients, Fourier series coefficients. So this K can be minus infinity to plus infinity, okay, integer, okay. So plus or minus integer, maybe 0, 1, 2, 3 up to infinity, minus 1, minus 2, minus 3 up to infinity, okay. So this kind of integer, this AK, you already know this, okay. So I hope you have I hope you have idea about this, okay. You have I think you have gone through the video, okay. Maybe you haven't go through my video, but I think using external resources, using external resource or something, you have already know this, okay. Because I have uploaded the note, okay. In the note, all these properties are there, okay. Actually, that multiplication property and the time scaling property is also there in the note, okay. So I hope you have idea, okay. Okay, so this is Fourier series. When we get the Fourier series, so it is AK, okay. So say that in the same manner, okay, we have another signal. We have another signal, okay. And if we get the Fourier series representation for that signal, for this YT, let's say that the Fourier series coefficients are BK, okay. So these are coefficients actually, okay. So it is not one number, one value, okay. So these are complex value, you know that, okay. So this may be a complex value, set of complex value, no. So this is a set of complex value, okay, because these are coefficients, okay, Fourier series coefficients, okay. And so okay, so let's say that we have like this, okay. So let's say that then, okay, then say that, okay, say that if we multiply by this signal using a scale, okay, if we multiply this signal by a scale, that means a number, a floating number, 1, 2, 3, 4, 5, like number, okay. So let's say that this is multiplied by a, okay. So this is a number, okay, any number, scale means number, okay, any number, okay. And this YT, let's say that we multiplied it by b, okay. And if we add these two, okay, it will generate another signal, no. It will generate another signal. So I think you already know this. We have seen this in the MATLAB also, okay. So it means that a xt plus byt, okay, byt a xt plus byt, we have another signal. Let's say that it is zt, okay. So this is another signal, okay. So are you clear up to this level? Can someone feedback, or do you have any problem with this? Okay, actually we have already talked about composite signal, no. Composite signal, that means we have several signals. We have several signals, sine signal, cos signal, and maybe DC component, okay. And also adding together, and we have another signal, no. So can you remember that? We have taken this as one signal and this as another signal, okay. And this also as another signal, okay. Can you remember? Okay, so I think we have already find the Fourier series of this kind of signal, okay. we have already find. Okay, so so do you have any problem? So you know that if you add cos omega t, let's say that sine 2 omega t, so you will get another waveform, no? Another waveform. We have seen it in MATLAB. Can you remember? Okay. So are you okay up to this level? Can you understand what I'm saying here? Can anyone feedback? Can anyone feedback, please? Are you clear up to this level, or do you have any problem? Can we go further? Okay, thank you. Okay, so okay, so if we have gotten, okay, so sorry, okay, so so you can say that we have multiplied by this signal, okay, with A, and we have multiplied by this signal with B, and we have add them together, no? So we will get another signal, is a T, okay? So this is a T will get, okay? So if we find the Fourier series of T, okay, Fourier series coefficients of T, okay, so we will have this kind of coefficients, A k plus B k, okay? So this kind of coefficients we will have, okay? Okay, so we will do one example to we will do some example to illustrate this. Okay, so okay, I get, so we have a signal xt. Okay, so that signal is, let's say that it is cos 2 5, let's say 105 t. Okay, so this is one signal 105 t. Okay, let's say that we have a 105 t plus let's say that okay, let's say that 5/2. Okay, so this is one signal. Okay, and we have another signal yt, that is sine 205t. So this is the second signal. Okay, so this is our first signal, and this will be our second signal. Okay, so can you find the Fourier series coefficients of, okay, Fourier series coefficients of, when I am saying Fourier series coefficients, it is complex exponential Fourier series coefficients. Okay, a complex exponential Fourier series coefficients. Okay, so I think now you have already familiar with these terms. Okay, so it will be complex. Please find the complex exponential Fourier series coefficients. Okay, for this xt and yt. Okay, so can you do it? Please take some time and try to do this yourself. Okay, so first try to do this and send me the coefficients. Send me the coefficients by chat. So I will give you around 10 minutes. Okay. So now, yeah, so 50:30 at 50:30 p.m. Try to do this, and before 50:30 p.m. try to send some answer to me. Please do this. If you want, you can talk with your friends, okay? I'm not going to disturb you, okay? You can ask your friend, okay? You can talk with your friend. Only 12 participants are there, no? Okay. I'm not going to hear your conversation, okay? You can talk with you guys, okay? So I will be back at 3:30. Okay, I hope you will have some answers. Okay. Okay.